I have 7 minutes to do this. 7 minutes. 7 minutes. BiPartrie, Trident, state and data for internal representation, CISCO corruption model. Basically, there's a lot of corruption happening in the UK system, and I don't want to be part of that via the CISCO protocol. And remember, that's a sort of I for India, Jupiter code, I for India, I for India. This is basically on the probing system, human rights probing system. Well, this is in CISCO protocol. So I'm gonna be not rushing this work, but I'm gonna go to my ward round. But this is very basically in CISCO protocol in action. So I'm gonna just explain to you things. So if you go to here, github.com/obnexus, O for Oscar, B for Bravo, I for India, and remember E for Echo, S for Room, etc. Equal to Mark 2. This is our the repository. But you're gonna have to grant Mark 2. You go Mark 1, just obnexus. We can download all the stuff here. If you click here, enter. You have the PhD milestones. You can get a release of the files v2 finished version. The latest one to the system. Because this is obviously the patents repository. OBNS's Cambridge drama is done. Just trying to build in Cambridge. The passwords. These are not real passwords here. This is Guardian Protector passwords in the project developers. So you can understand these are proofs here. Let's pick a file. Let's pick a file. Filter Flask initial evolution. Okay. This is the mathematical tool we're working on. Named OBS Execution Division. AGIS, we should see. OBI. Ontological OBI or hot AI, filter flash cognition evolution, ontological Bayesian infrastructure for dynamic reasoning. Yes, this one is very important. It's basically on systems of non-linearity or dynamic systems. Dynamic reasoning, this is like a via dilemmas, like chicken and egg dilemma. The OBI filter flash model extends hard AI cognition native code to dynamic modeling solution by filtering persistent symbolic interference and flash ephemerik, again of knowledge, the region of knowledge, working memory. The system introduces this new condition calling the cost a function or traversal because English 1 and 2. This is proof 1 and 2 of multiplicity, but this is here no stop. So cost. Building on the established OBI foundation, C, K, sub T, S equals H, S times E, landscape, cost knowledge function, where it's semantic inventory, and KT is something to knowledge at a time. But it's very important to have this works in 10, this works in 7. So it's basically a filter, flash, working memory system. So flash means filter means sorting out. Flash means storage. So working flash means storing stuff effectively. Flash. Filter means more flash, and then more less filter and same. But you're gonna have this for instance, capsule. CBD the code. Okay, basically the now classifier model, but this is working as intended. I get the don't work my work with it here. So this one, but the next step is to actually build the AI system. Basically, this is ontological Bayesian intelligence infrastructure. BIER. But also those two hypotheses. Gonna have the hypothesis on unaddressed hypothesis 5. So traditional AI is owned by this model. Black box bias linear, structured. Inputs, co-founders, confounders, like things that are demographic data, Bayesian network bias parameters to tune out the bias, tune in bias, but the tune out bias. The bias parameters way fake the Bayesian network, and still have a debiased output. Instead, we're gonna have. This is a study project. This is the first one I wrote. But Kane and clustering. I made a dimensional gesture. Full detail to 3D space. Semantic understanding. We will pull a semantic graph. Gonna have cadence, this is a clustering algorithm based on problem. It's a clustering algorithm based on kind of sparse data. So this is my work here. Okay, now the main point I'm gonna have with you guys is like, if you guys can see what I'm saying here. So this is I'm gonna tune into my screen. We'll see what's happening here. So let me start this. I'm gonna see what I'm gonna do my screen switch. So here, so we're gonna have two main things happen here. So I'm gonna explain the paper not in board. So let me use the proposal of the truth out. So the model of the symbolic system. But all my work is there on github.com /openness patterns. P for Papa, A for Alpha, F2 tango, E for Echo, N for 2 tango, F7. But I want a peer review. What I want is a peer review. I want to do my work, it's a peer review. Well, someone can contact me directly and tell me what is actually buildable. But I spend my blood, sweat, and tears in this work. This is my own AI engine. But I want to do one more video to conclude it. Basically, want to start a new something AI system. But I know they do work. I just don't have the money to build it. So I'm going to enjoy to do that. Build my AI systems. So we're gonna have the here. So we're gonna have here. So basically, what we're gonna talk about is very important to understand how it's probing. So this is lessons about some probing. So what's the title of the probing system called? The title of the probing system is called BiPartrie Trident station data internal system. So basically, the problem is data styles. They're really different data styles, but you need the data, so you have to get it from data. And this is the proof stuff giving the data style. You just need some data for the time being. So these styles, you need them, yes, you need them in data centers. These styles. They're centralized. That means if you move away from the earth, you're centralized, you're gonna get updates. But this is problem system cells. So for example, we're gonna have a BiPartrie Trident state. So we're gonna have a Trident state, something that so we're gonna have three states. No, yes, maybe. Now these are three this system models, but they are CISCO models. So they have three filters. This view is this is a Trident state. So they have they have states and data where P given S implies D. So this will prove that the pro is given to column S implies D. So the state where P is a pro, S is a state, and D is data. So you're gonna have the union between state and data. So unity is data. So if I remember correctly, P. So I'm trying to give you the formulation of them. But basically, the three states that have yes, no, no. But they have yes. So S contains every element of D B3. So every time you have a state, you have three rotations. Yes, no, no. And it's symbolic. It's symbolic win. So you have the symbol. So if you have a CISCO model, a CISCO state. So if you have a CISCO state, which is complex CISCO, so we're going to do CISCO. C equals CISCO complex instruction sets. CISCO model is the bottom-up model of execution, which is equal to the execution order. You understand that I'm trying to give you a formula. If you're drawing maths now, But the goal is to have all this yes, no, yes, yes, no, no, maybe, maybe. B have a meaning. So anything have an interpretation. Doesn't matter what the computer says. There's three poles. And these are the three poles. Yes, no, maybe. But they have an interpretation that's chemical. So when it's all verified, this is called the civil language model. So it's called the civil language model. So let me get the civil language model here. Let me show you here, guys. If I forget it. Get home. So 1 second, guys. So it's got XYZ grammar. It's a good grammar here. So this one's saying, this one to show you guys here. So what I'm saying. So this is simple language model. So you're gonna have XYZ evolution going on. You're gonna have latitude, longitude, and altitude. So you're gonna X, Y, and Z. This is called an LM, this is called a CBD language model. So you're gonna have this to try to rule them on system. But this is an interpretation fact. So you're gonna have the grammar of X here. But this is called LLM. So in simple language model, it's computer framework to preserve traditional Igbo ideography. Doesn't matter the glyph. So a glyph is a dynamic symbol. It has auto. So you can have low tone and high tone. But you can have authenticated sequences of low tone and high tone based on the interpretation too. But you're gonna have a symbol. Now, symbol is very important to stamp. It's just the glyph. It's just the edges or mark. Like letters are symbols. Yeah. Letter symbols. So you're gonna have the X here, coherence spectrum, features of fractional, reasoning formality, informative formal, and conversation evolution. But it goes to how it's from. So if it's conflicting, if you have a voting and they don't really add up the XYZ grammar. Say this pole, this X grammar does not line up with the Y grammar, what it means in kind of in the lexical the parser, the meaning, there is a conflict because 2/3 don't line up. These two representations don't line up. The correlations of a fraction, the fiction or the fraction doesn't match. And you have a problem there. And the symbol will then probe this. So this works on the data. So the data becomes the Lexa information for the next input, and it still can evolve that way. But it's a symbolic interpreter engine. So the X represents coherent spectrum, minus X methodology, fictional and factual. The Y represents information, information, formal, and Z is basically dynamic to static. Static dynamic. So the more static information is, the more reason it is. But they all map onto the grammar of languages. Yes, no, maybe. This is basically for modeling internal states. Now, internal symbols of encoding. So we know what the EI is talking about because we are from Igbo PLA system. This is basically an EI system that's going to stamp the root of Nsibidi. And Nsibidi is a Niger Congo language. So it's going to work on the kind of the state of transition of the internal representation of the CISCO. Now, CISCO corruption, but you have a corruption model in place. Now, the corruption model is basically now, the corruption model basically ensures that system doesn't decohere to decorruption model. Yes, I'm busy. No, tell me, talk to me. No, don't come here in front of me. Go ahead, what do you want to say?
Would you like to come down to the football? We're going to go get some open the double doors to the tennis courts and play some sports in the sunshine.
Sports in sunshine? Oh, outside? Mm-hmm. Well, I'm coming after. I've got my wardrobe now.
You've got your wardrobe?
Yeah, too.
Get somebody to bring you down and some sports on.
Okay, thank you. So the BiPartrie Trident state of the data model usually takes the data and does the lexical parser of the mission and becomes a signal model. So they're going to have a corruption model too for corruption. But you understand that it's consensual. It works on consensus. So it's basically anything you're gonna have will basically fit into the CBD language model. And the model is basically phonetic accessibility, lips mitigation. So basically, the AI system cannot make a mistake to religion, but it's an AI system. So this is the AI system. This is what I'm building. So this is what I'm really building here, guys. So you're gonna start using root core, root version reset. I'm gonna have a model, but this is what the probing system does. So probing system probes the software input to see whether it's saying it right and doing it right in a nutshell. Thank you guys for watching the video. Thank you guys for watching the video.